Hello, welcome back. This is going to be a video on graphing your first polynomial. I am looking at page 10 in the 3B packet, and I'm looking at the very first example. So it says graph by hand and analyze the polynomial function. So we are going to go through the steps A, B, and C on page 10. And then eventually D and E on page 11, and that's where we'll end up sketching the graph. But first, we just like to look at the different qualities of the graph. And the first thing we do for that is applying the leading coefficient test. So if I look at this function, my leading coefficient is 1, so that's positive. And my degree is 3, so that's going to be odd. So if I were to draw a little picture, this is what I would draw. This is just how I know how I'm going to end up describing the left hand and the right hand end behavior. So on the left side, I have as x approaches negative infinity, f of x will approach negative infinity as well. On the right side, as x approaches infinity, f of x also approaches infinity. So there's my end behavior. And I found that out by looking at the leading coefficient of 1 and the degree of 3. So now my next step is to find all of my intercepts, my x-intercepts algebraically. And I do this by factoring. So I'm going to set this equal to 0. So 0 equals x cubed minus 9x. So my first factoring that I see is I have a GCF of x. I'm going to take out x, so I end up with x times x squared minus 9. From here, x squared minus 9 is a difference of squares. That's going to be really important to pick out as we go through all of these examples. So that'll be x plus 3, x minus 3. So now I can see 3 different factors. I'm not going to have multiplicity on any of them because I don't see multiples of any of the factors. So I have x equals 0, x plus 3 equals 0, and x minus 3 equals 0. So from here, I know I have x equals 0 is one of my x-intercepts. X equals negative 3 is one of my x-intercepts, and x equals 3 is an x-intercept. So these are going to be my 3 x-intercepts. This is probably the most important step to be able to do in this entire process. Factor and solve, find your x-intercepts. The y-intercept occurs when you plug in x equals 0. So if I just take that original function, x cubed minus 9x, and I plug in 0 for x, I can find my y-intercept. So I get 0 minus 0, which is 0. So the y-intercept is going to be 0, which makes sense because x equals 0 is one of my x-intercepts. So now I'm just going to double check to see if this is even, odd, or neither. And the way that we do that is we plug in to the function. So f of x equals x cubed minus 9x. So my first move is to find f of negative x. F of negative x equals negative x cubed minus 9 times negative x. So that's negative x cubed plus 9x. That is not equivalent to f of x, so it's not even. So now I do negative f of x. So I'm multiplying the entire function by a -1, which gets me to negative x cubed plus 9x, which is equivalent to f of negative x, which makes the function odd. So just a quick recap on this page. I've got x cubed minus 9x. I know my end behavior. As x approaches negative infinity, f of x approaches negative infinity. And as x approaches infinity, f of x approaches infinity. I have my x-intercepts, which I found by factoring and then solving. And I have 3 x-intercepts, which makes sense because using the fundamental theorem of algebra, I can tell that because the degree is 3. Then I found my y-intercept by plugging in x equals 0. And I got the y-intercept of 0, 0. And then lastly, I found that the function is odd because I found f of negative x to be negative x cubed plus 9x. And negative f of x is also negative x cubed plus 9x. So since f of negative x equals negative f of x, that makes the function odd. So now I'm going to flip to the next page. The important thing to take to the next page is mostly these 3 parts here. The most important thing to take to the next page is this x-intercepts bit here. So I have x-intercepts at 0, -3, and 3. So I'm just going to make myself a little note up here. X-intercept are 0, -3, and 3. And to be honest, when I go onto my graph, I actually like to graph those first as well. So I'm going to go onto my graph and graph them right now. So I have 0, 1, 2, 3, -3, and 1, 2, 3, +3. Another thing is that I know it should go down on the left and up on the right. So this is kind of a note about how my end behavior should be. And now from here, this is the part next to the x-intercepts. This is the next most important part. So what I need to do is find different values in between these intervals. So I actually want to find a value on the left, in between -3 and 0, in between 0 and 3, and then on the right of 3. So I know this has 3 different intervals. I'm actually going to end up finding 4 because I like to find what happens in between each 0 and on the outsides of zeros. So the first interval is from -infinity up to your first 0. So your x-intercepts are really what your intervals come out to. So -infinity to -3 is my first interval. My next interval is from -3 to 0. Then I have from 0 to 3. And I'm actually going to do another row for 3 to infinity for my own sanity. So now the reason why we make these intervals and we pick x values between them is to figure out what happens between each 0. It might go like this. It might bounce off of them. It could do a number of different things. So you just want to see what points are between it. So from -infinity to -3, I need to pick an x value within that interval. I am just going to pick the one closest to -3. I'm going to pick -4. Between -3 and 0, I can pick any value. I can pick -2 or -1. I'm going to pick -1. Between 0 and 3, I'm going to pick 1. And between 3 and infinity, I'm going to pick 4. Again, you can pick -1, -2 between these two. You could pick a fraction if you really wanted to. It doesn't really matter as long as you're picking something within the interval, and your intervals are always defined by the spaces between your x-intercepts. So if I chose -4 as my x value to find f of x, so to find the y value or what the point is going to be, I need to plug in -4. So -4 to the third minus 9 times -4. So -4 to the third is going to be -64. Make sure when you're raising a negative to an exponent, you're using your parentheses if you're using a calculator. So I've got -64, and then -9 times -4 is going to make this plus 36. So I get the value of -28. So that point on the graph would be -4, -28. So now I'm going to go to my next point. So if I'm plugging in -1, -1 cubed minus 9 times -1. So that gives me -1 plus 9, which is going to be 8. So I have the point -1, 8. Now my next point is 1. So 1 cubed minus 9 times 1, and I get 1 minus 9, which is -8. Why do I keep doing that? So I've got 1, -8. Almost did it again. And for my last point, I have 4. So 4 cubed minus 9 times 4. So I've got 64 minus 36, which is going to be a positive 28. So I've got 4, 28 for that one. So once you know what's happening between each point, now you're going to plot these points. So I know I can't plot these ones, but what I do know is that it's going to go down pretty steeply over here. I'm just going to plot the points that fall on the graph. So -1, 8. And then 1, -8. So here is what I know. I know it's going down on the left. I go up to this point, and the only time I come back to the x-intercept is when I actually have an x-intercept. So this is just a rough sketch of what it should look like. What's really, really important to recognize is that I only go through the x-axis where I initially found x-intercept. So I travel to each of these points, and then I travel back to each of the x-intercepts, and I only cross if I need to get to another point on the other side. So this is your first example of graphing polynomials. I know that this is kind of a tricky skill, and we will definitely do a bunch of practice.